So for the second one, part B, we've got z cubed minus I equals 0. So same start as we had before. We'll add the I to both sides. So we've got z cubed equals I, and we'll think, where is this on the Argand diagram? And I, of course, is just straight up there. It's got a length of 1 there, and this angle here is pi over 2, 90 degrees, pi over 2. So if we rewrite this now using our modulus argument form, it's one lot of cos pi over 2 plus I sine pi over 2. Ignoring the 1, as we did before. And again, as before, rather than just having this one angle here, this one time, why not go all the way around the circle and get there again? And so instead of just pi over 2, we could add 2 pi times by k. And we could do that as often as we like, depending on how many times we spin around the circle. So we've got that bit there. And that's what z cubed would be. To find out what z is, we're going to cube root this side to the power of a third, and we'll do this to the power of a third as well. And using de Moivre, this 1/3 can come into this bracket here. So all of this over 3 and all of this over 3. I think we'll tidy that up now. I've been trying not to write too much. So that's going to give me, what, pi over 6 plus 2/3 pi k. And I sine pi over 6 plus 2/3 pi k. And once, like before, we just got to put different values of k in to try and do that. But I'm going to use the calculator to try and save us some time on this here then. So the first thing I'm going to do is I'm going to stick 0 into k. I'm going to use a k just so that I don't have any different issues. So I've got 0 into k here. And now this complex number that we're doing was the same as 1 with its modulus, because we have just the modulus of 1 there as before. And then the angle we're working with is, and I'll get this in a bracket, pi over 6 plus 2/3 pi k, like that. And we want to change that into its a plus bi form. So remember, in your options, complex numbers, change it into a plus bi form. I'm going to, just in case, I can't remember if I need it or not, I'm going to stick another bracket around the whole thing, just in case it doesn't work. I can't remember if you need it or not. So when k is equal to 0, look what we get. K is equal to 0. I've got root 3 over 2 plus a half I. That's nice. There's the first answer. K is equal to 1. So all I've got to do now is just go up there and change that to a 1. Bum, 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 and it gives us minus root 3 over 2 plus a half I. Okay. And now go up here again and change this to a 2. And it goes, and k equals 2. Well, that gives us the minus I. Minus I, we were probably thinking it was going to be minus I, weren't we? And so here are our 3 answers. All the calculator's done is saved me having to tap that in lots of times. I've just done it and repeated it over and over again. If we did go back and try another one, if I now put 3 in here, and it goes and of course you're back with that first answer again. So you'd know that you could stop there, although you should know there's 3 answers because it's a cubic.